We are surrounded by incredibly powerful AI systems making huge decisions about our money, our health, our lives. But here's the problem. A lot of these systems are a total mystery, even to the people who built them. So today, we're going to pry open that AI black box and ask a really important question. Can we actually trust machines we don't understand?
All right, just picture this for a second. You find the perfect house, you apply for the loan, and you get rejected. So you ask the bank why, and they just shrug and say, sorry, the algorithm said no. They can't give you a real reason, not because they're hiding something, but because they literally don't know. This isn't some sci-fi movie plot, this is a real problem we are dealing with right now.
And this image, this nails the entire issue. Over on the left, you've got the black box. We feed it data, like our loan application, and we get a decision out. But what happens in the middle? Who knows? It's a total mystery. The goal is to get to what you see on the right, Explainable AI, or XAI. This is where the system doesn't just give you an answer, it gives you the why behind it. That's how you build real trust and accountability.
So, let's really dig into this black box problem. We need to understand why it even exists and what happens when the power of our own technology starts to outrun our ability to understand it.
You know, the very thing that makes these AIs so incredibly powerful is also their biggest weakness. I'm talking about deep neural networks. These things have millions, sometimes billions of connections, and they learn patterns that are way too complex for any human brain to follow. They get scarily accurate results, but they do it by sacrificing every last bit of transparency.
And the consequences of flying blind like this are huge. I mean, think about it. How can you trust a system you can't see inside of? What happens when a hidden bias creeps in and it starts making discriminatory decisions? And when it messes up, which it will, who's on the hook? For the developers, it's a total nightmare. How do you fix a bug you can't even find?
In some fields, this isn't just an inconvenience, it's a complete deal breaker. We're talking about high-stakes situations where these decisions can literally be the difference between life and death.
Take medicine, for instance. This quote gets right to the heart of it. A doctor can't just take an AI's word for it on a diagnosis if the machine can't explain its reasoning. They have to be able to justify their decisions to the patient, to the hospital. An unexplainable recommendation isn't just useless, it's a massive liability.
And you can see how urgent this is for the medical world. Check out this number, 1,824. That's how many studies a recent major analysis found when they just started looking into XAI for medicine. The demand for answers is clearly there. But here's the kicker. After they filtered for research that was actually high quality and relevant, that huge number, over 1,800, dropped all the way down to just 62. That massive difference tells you just how hard this problem really is to solve. This is not easy stuff.
And this chart shows us exactly where the focus is. Radiology, oncology, neurology, fields that are all about interpreting complex images, and it makes perfect sense, right? A radiologist needs to know what part of an MRI the AI is flagging to even begin to trust its conclusion that a tumor looks cancerous. Okay, so we've laid out the problem pretty clearly. Now let's talk about the solution. It's time to unlock this box and finally turn on the lights with something called Explainable AI.
Now, XAI is not about dumbing down our AI models. It's actually about making them smarter, just in a totally different way. The whole goal is to build systems that can justify themselves, so that we, the human users, can actually understand and trust them. It's all about building that bridge between machine logic and human intuition.
One of the most popular tools to do this is a technique called LIME. Now, instead of trying to map out the entire ridiculously complex AI brain, LIME just focuses on one single decision at a time. It's like asking the AI, okay, forget everything else. For this specific loan application that you just denied, what were the top 3 reasons? It builds a simple, local explanation for just that one case.
The way it works is actually pretty simple. It just pokes the model. It makes tiny little changes to the input, like what if the income was 5% higher? And it watches to see if the decision flips. This helps answer those critical questions, like, was my income the real deal breaker? Or was that one tiny spot on the X-ray the only thing that mattered?
All right, then there's another powerhouse technique called SHAP. And this one's really clever. It actually borrows a concept from game theory. Its whole job is to figure out how to fairly distribute the credit for a final decision among all the different pieces of information that went in.
So think about it like this. If the AI model is a basketball team and the final decision is the final score, SHAP is the statistician that tells you exactly how many points each player was responsible for. It tells you precisely how much your age, your income, and your credit history each contributed to the final outcome, whether it's good or bad.
So let's put these two head-to-head for a second. As you can see here, LIME is awesome for getting quick, intuitive answers for one specific case. Its main downside is that it can be a little unstable sometimes. SHAP, on the other hand, is kind of the gold standard. It's rock solid, consistent, and gives you the big picture and the small details. The only trade-off? It can be an absolute beast to run. It takes a lot of computing power.
Okay, so we've got these amazing tools like LIME and SHAP. Problem solved, right? Well, not so fast. Just as the tech is creating solutions, a whole new challenge is popping up. The regulators are finally catching on. We're seeing these huge new laws, especially the EU AI Act, that are basically making explainability a legal requirement. It's not just a nice-to-have feature anymore. If your AI is being used for high-risk stuff like medical devices or hiring, you are now legally required to be transparent. But the million-dollar question is, are these companies actually ready for that? And here's where it gets messy. According to the people actually building this stuff, like this senior data engineer, the law tells you what you have to do, be transparent, but it's super vague on the how. That vagueness makes it almost impossible for companies to know if the explanations they're providing are actually good enough to satisfy the law. And then there's this critical point from an industry CEO. This is the fundamental dilemma. Often, the most accurate AI models are the most complicated and confusing ones. If you force them to be more simple and easy to understand, you can actually lose some of that predictive accuracy. It's a constant balancing act. So what's the big risk here? An AI governance expert warns that without clear rules, companies might just do the bare minimum to check a box for the regulators. They could use cheap, superficial explanations that technically follow the law, but don't give anyone any real insight. It creates this false sense of security, which is almost worse than no explanation at all. So where do we go from here? The path forward isn't just about writing better code or clearer laws. It's about a much bigger shift in how we even think about what an explanation is. It's about designing our systems for trust right from the very beginning. One really promising idea is something called the TMEA framework. The core idea is actually simple, but it's incredibly powerful. One size does not fit all. The best explanation totally depends on what the task is, what kind of data you're looking at, and, most importantly, who is the person that needs the explanation. Let's walk through that doctor example again. The task is to diagnose the tumor. The data is a medical image. So the best explanation isn't going to be a giant spreadsheet of numbers. It's going to be a visual heat map, something that highlights the exact spots on the scan that the AI is worried about. And then, the most crucial step, you have to test it. Does that heat map actually help the doctor make a better, more confident decision?
And that right there is the big shift in thinking. We need to stop asking, how can we explain this model, and start asking a much smarter set of questions. Who is this for? Is it for the developer, the regulator, the doctor, the person who got denied a loan? And what do they need to do with that information? Context is everything. Which brings us to the final and most important question. As AI gets tangled up in every part of our lives, the real challenge isn't just technical, it's about us. It's societal. We have to decide what our standards are going to be. So I'll leave you with this. Are we prepared to demand not just answers from our machines, but real, genuine understanding? Because the choice we make will define the future for all of us.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.